So if you buy the wrong doorknob for your house, it's annoying.
Oh, yeah. Very.
Right. You drive back to the hardware store, you swap it out, and you basically just move on with your weekend.
Exactly. It's a minor inconvenience.
But imagine you're building a massive multi-million-euro facility.
Okay, slightly higher stakes.
Just a bit. And a contractor installs this really heavy, highly specialized door, but the door reduces sound transmission by 44 decibels instead of the specified 45.
Which, to clarify, is tiny.
Right. In our everyday lives, a 1 decibel difference is literally imperceptible to the human ear. You wouldn't even notice. But on a modern mega project, that single decibel is, well, it's a mathematical breach of contract.
It's a huge deal.
It is.
Yeah.
It could result in an independent inspector rejecting the entire installation, forcing the contractor to tear out a whole wing of the building, and just grinding a highly coordinated timeline to an absolute halt.
And that is not an exaggeration, by the way.
No, not at all. So, welcome to this deep dive. Today, we are exploring a highly technical, real-world scope of work document that is specifically tailored for building and architectural works.
And, we are not just looking at a standard list of tasks here.
Yeah.
This particular scope of work operates under the FIDIC Conditions of Contract for Construction Red Book 2017 edition.
Which is a mouthful.
Yeah, it really is. And for anyone outside the heavy construction industry, that name might not mean much at all. But it is the absolute gold standard for international infrastructure mega projects.
Right.
So our goal today is to demystify this dense, honestly intimidating blueprint for you. We want to show you the hidden, incredibly rigid matrix of rules, materials, and accountability that allows a sprawling project to go from, a two-dimensional drawing to a physical reality.
Okay, let's unpack this, because looking through our sources today, I realized this document isn't just a basic manual for builders.
No, far from it.
It actually reminds me more of the DNA code of a living organism.
No, that's an interesting way to look at it.
Yeah, because in biological DNA, if a single gene mutates, the entire organism can suffer, right?
Right, yeah.
Reading this scope of work, it feels the exact same way. If one material doesn't perfectly match its mathematical specification, like that 1 decibel difference in a door, the entire system is basically compromised. The building leaks, or it fails a fire inspection, or worse.
What's fascinating here is what the FIDC Red Book 2017 framework actually achieves.
Yeah.
Yeah. FIDIC is a global standards organization, and their Red Book is designed specifically for projects where the employer provides the design and the contractor simply executes it.
So the contractor doesn't design anything, they just follow the instructions.
Exactly. And in a project of this magnitude, you have hundreds of subcontractors, thousands of workers, and literally tens of thousands of moving parts.
It's a massive logistical puzzle.
Right. And without a definitive line in the sand, establishing who holds the risk for every single screw and every single drop of paint, you would have complete anarchy.
Total chaos.
Exactly. The Red Book turns that chaos into an uncompromising, legally binding reality.
Which brings us to what I'm calling the pregame.
Ah, yes, the paperwork.
So much paperwork. Because before we can even talk about pouring concrete or raising steel, we have to look at the invisible safety net that gets constructed before a single tool is lifted on site.
Yeah, the general obligations.
Right, the general obligations of the contractor. And the timeline demanded here is just incredibly aggressive.
Oh, it's brutal.
Under subclause 8.3 of the FEI rules, the contractor has exactly 28 days from the official commencement date to submit a microscopic, heavily detailed construction program.
And, that 28-day window is really just the beginning of the paperwork.
What? There's more?
Oh, yeah. The contract mandates that at least 21 days before the contractor starts any critical activity.
Like what kind of activity?
Like pouring structural foundations, installing waterproofing, or putting in fire-rated systems. Before any of that, they have to submit a formal method statement.
I actually saw that in the sources. But a method statement isn't just a brief summary saying, hey, we plan to build the wall on Tuesday, is it?
Not at all, no. A method statement is a comprehensive engineering and logistical defense of how the contractor plans to execute the work safely and correctly.
Defense? Like they're on trial?
Basically, it includes the exact sequence of events, the specific mix of materials, where the cranes will be positioned, how the weather will be monitored, and all the safety protocols for the workers.
Wow.
Yeah, they have to mathematically prove how they're going to do the work before they are legally permitted to touch the site.
That is wild. And that actually ties into a recurring character I kept noticing in the sources, the quote-unquote engineer.
Ah, yes, the engineer.
Throughout this SIDI framework, specifically in subclauses 7.3 and 7.5, the document outlines this really obsessive need for the engineer's no objection.
Yes, the engineer is a crucial figure. In FIDIC contracts, the engineer is an independent third-party professional appointed by the employer to administer the contract.
Okay, so they're the referee.
A very powerful referee. They hold the absolute right to inspect every stage of the work,
Yeah.
test the materials, and summarily reject anything that is non-conforming.
And it goes beyond just standing on site with a clipboard, right?
Oh, way beyond.
Because under Section 4.2, the contract mandates that for every single architectural finish or system, the contractor has to submit physical samples.
Right.
And not just a swatch fabric or a little paint chip, they actually have to construct full-scale sample panels and physical mock-ups.
Which is a massive undertaking.
Yeah. I mean, sometimes they are mandated to build an entire square meter of a brick wall just to get a written no objection from the engineer so they can commence the full-scale procurement. Which brings me to a genuine question here. Is this engineer essentially a dictator?
It can certainly feel that way to the contractor.
I mean, why does a highly experienced multi-million-euro contracting firm need to build a tiny sample wall just to get permission to buy a standard brick? Doesn't that just grind the entire momentum of a project to a halt?
It sounds incredibly bureaucratic, yeah. Maybe even pedantic from the outside looking in.
Very pedantic.
But you really have to view this through the lens of the massive financial and safety stakes involved.
Okay, fair enough.
This specific contract explicitly states that the currency of payment is the euro. And when you are operating on a project using euros at a mega project scale, a tiny deviation doesn't just cost a few $100.
It scales exponentially.
Exponentially. If a contractor bypasses that mock-up phase, buys, say, 50,000 hollow concrete blocks, and builds an entire wing of a hospital.
Oh, no. I see where this is going.
Yeah. And then the engineer discovers those blocks don't meet the acoustic requirements. You can't just paint over a structural acoustic failure.
You'd have to tear it down.
You have to demolish the entire wing.
Wow. The financial liability of tearing down a completed wing would bankrupt most companies.
Precisely. And that is why subclause 4.1 is really the philosophical core of this entire document.
What does that clause cover again?
It emphasizes the concept of fitness for purpose.
Fitness for purpose.
Right. The contractor isn't just obligated to build a wall. They are legally obligated to build a wall that perfectly serves its intended architectural and engineering function.
So it's not just about aesthetics.
Not at all. The building isn't just a physical object. It is a legal object manifested in physical space.
A legal object. I like that.
Yeah. So those mock-ups, along with the strict adherence to ISO 9001 for quality management and ISO 45001 for health and safety, those are basically mechanisms of survival.
Right. Because ISO 9001 isn't just a vague commitment to, like, being good at your job.
No. It is a verifiable, highly rigid audit trail.
Yeah.
So the engineer isn't being a dictator. The engineer is enforcing a mathematical certainty of success to prevent catastrophic loss of capital and, potentially, loss of life.
That completely reframes the bureaucracy for me. It's not red tape. It's an empirical reference standard.
Exactly.
If the final wall doesn't match the approved mock-up, there's no debate.
Not at all.
So the rules of engagement are set. The safety net is up. The mock-ups are approved. Now we transition from the legal framework to the actual physical anatomy of the build.
The fun stuff.
Right. Because looking at the work breakdown structure in this document, the WBS.
Yes, the famous WBS.
Here's where it gets really interesting. Reading this WBS is like looking at the most intense taxonomy of materials ever conceived by human minds.
It really is. The work breakdown structure is brilliant because it assigns a unique numerical code to every single component to prevent total anarchy.
It's that DNA sequence again.
Exactly. You mentioned earlier that this is like DNA. The WBS is the sequencing of that DNA. The 600 series handles the architecture, with further subdivisions for structures, finishes, and services.
I was looking specifically at WBS 627, which covers blockwork and masonry.
Oh, okay.
And it starts normally enough, you know. It asks for standard 150 millimeter hollow concrete blocks.
Yeah, very standard.
But then it rapidly escalates. Suddenly, the contractor is required to procure a, quote, scoria blend block that guarantees exactly 2, 3, or 4-hour fire insulation.
Right.
What exactly is a scoria blend, and how does a block of masonry guarantee 4 hours against a raging fire?
Well, scoria is actually a highly vesicular volcanic rock.
Wait, volcanic?
Yeah, from a volcano. When a volcano erupts, the trapped gases in the cooling magma create this incredibly porous, lightweight stone.
Oh, wow.
And because it is filled with all those tiny air pockets, it acts as a phenomenal thermal insulator.
That's amazing.
It really is. By blending scoria into the concrete mix, the block literally stops the transfer of heat.
Okay, so why is that so critical for this building?
Because in a massive facility, if a fire breaks out, standard structural steel will warp and buckle under extreme heat in minutes. Minutes, which leads to a total collapse. But the scoria blend blocks isolate the heat, giving the firefighters exactly 4 hours to extinguish the blaze before the structural integrity of the surrounding areas is compromised.
4 hours to save the building.
Exactly. It is a beautiful example of utilizing ancient volcanic properties for modern engineering safety.
It is wild to think about volcanic rock being mandated in a modern legal document.
Yeah, you don't expect to see that in a contract.
Definitely not. And right after that, under the exact same WBS section, it demands pre-finished gypcrete panels for load-bearing walls. And it actually notes that they're so massive, they explicitly require craneage.
Right. Gypcrete. That's a high-density gypsum concrete.
How is that different from regular drywall?
Oh, it's completely different. Unlike standard drywall, it is incredibly heavy and dense. It's used for extreme load-bearing or severe acoustic deadening between really sensitive zones in a facility.
So you can't just have a couple of guys carry it in.
No, they're so dense that manual labor can't place them. The contractor must engineer specific crane pathways just to swing them into the building footprint.
Just incredible planning required. And, the granularity extends to the doors as well.
Doors.
Under WBS 628, the taxonomy of doors is just staggering. Under 628.002, you have simple pivot glass doors.
Sure.
But slide down to 628.004, and the contractor must install a 1-hour fire-rated duct access door made specifically of zinc-anneal steel.
Zinc-anneal, yeah.
Why mandate that specific type of metal just for a duct door?
Because duct access doors live in a really harsh environment.
Really? A duct?
Oh, yeah. They handle constant moisture from condensation and severe pressure differentials from the HVAC system.
Oh, I guess I didn't think about the moisture.
Yeah. So zinc-anneal steel is steel that has been subjected to a galvannealing process, meaning it is coated with a zinc iron alloy.
Okay, so it doesn't rust.
It doesn't just prevent rust, it creates a matte surface that binds perfectly with paint while remaining highly corrosion resistant.
Ah, I see.
If a standard steel door was used there, it would rust, the seal would fail, and the HVAC containment for that entire zone would be completely breached.
The details are just endless. And a bit further down, under 628.009, we find solid core acoustic timber doors rated at exactly RW45.
RW45.
Which loops back to the doorknob analogy we opened with.
Yeah.
You explained that RW45 isn't just a random label.
Right. RW stands for Weighted Sound Reduction Index.
Weighted Sound Reduction Index.
Exactly. The decibel scale is logarithmic, meaning every single decibel represents a significant leap in sound energy.
It's not a linear scale.
No, not at all. So an RW45 rating means that specific door, along with its frame and acoustic seals, has been scientifically tested in a laboratory to reduce sound transmission by exactly 45 decibels.
Wow.
If a contractor tries to save money by installing a door rated at RW44, they are mathematically violating the fitness for purpose clause.
And the engineer catches it.
And the engineer will reject it outright under subclause 7.5.
Close enough simply does not exist in this vocabulary.
Never.
And you see this exact same obsession with precision in the building. Finishes WBS 630 and 633.
The finishes are where it gets really specific.
Yeah, for the roof, the contract doesn't just ask for, basic metal sheeting. It specifically mandates clip lock 700 BMT 0.70 color bond roof sheeting.
A classic.
And it stipulates it can only be used on roof slopes not exceeding 22.5 degrees. I have to admit, clip lock 700 BMT 0.70 color bond sounds like a password to a military server.
I can see that. But it is a highly specific engineering formula. Let's break it down.
Please do.
BMT 0.70 refers to the base metal thickness. So exactly 0.70 millimeters of ultra-durable steel.
Okay, that makes sense.
Color bond means the metal features a specialized oven-baked paint finish, and that's designed to withstand decades of harsh UV radiation without degrading.
So the paint won't flake off in the sun?
Right. But the most important part is the clip lock designation.
I assume that refers to how it actually attaches to the building.
Exactly. Traditional metal roofs are secured by driving hundreds of screws directly through the metal panels into the frame beneath.
Like nailing shingles.
Kinda, but every single screw hole is a potential leak point.
Oh, right, because you're putting holes in the roof.
Exactly. A clip-lock system uses concealed brackets attached to the frame, and the metal sheets literally snap or clip down onto those brackets.
That's brilliant.
There are 0 screw penetrations through the actual roof surface.
Which means no leaks.
Ideally, yes.
I see.
And the contract restricts it to a 22.5-degree slope to ensure that rain and debris shed at the exact required velocity.
The floors are equally regulated, too.
Oh, yes.
Looking at WBS 633, the document specifies a cementitious topping called pandomo, which legally requires an exact R10 slip resistance.
R10?
Or, if a space uses vinyl, it must be a Forbo Smaragd marble vinyl that is entirely chemical resistant.
This really highlights how aesthetics and safety are seamlessly integrated. Pandomo gives a beautiful, seamless, modern, concrete look.
It's very trendy right now.
It is. But R10 isn't just a suggestion to make the floors somewhat grippy.
Like, just put some texture on it.
No, it is a scientifically derived coefficient of friction, and it's determined through strict ramp testing protocols.
Ramp testing.
Yeah. If someone slips and injures themselves on that floor 5 years from now, the very first thing the legal teams will do is test the slip resistance.
Wow.
Oh, absolutely. If the contractor used an unauthorized sealant to save time, and that sealant dropped the friction from an R10 to an R9, the contractor assumes total liability for that injury.
So the paperwork and the approved mock-ups from the pregame, they actually serve as legal armor for the contractor years later.
Absolutely. The bureaucracy protects the contractor just as much as it protects the employer.
That makes so much sense. So having explored the physical shell, the clip-lock roof, the RW45 acoustic doors, and the chemical-resistant vinyl, our next area of focus within the sources is the inner workings of the building.
The services.
The services, yeah. And, crucially, the boundaries of what this contract actually covers.
Right. WBS 635 through 641 covers these services. This is the internal plumbing, the fire hydrants, the medical gas lines.
And the juxtaposition in this section is just striking to me.
How so?
Well, under WBS 638, the contract mandates precise plumbing connections for basic coffee machines and cafeteria Bain Marys.
Right.
But in the exact same paragraph, it mandates the plumbing for emergency safety shower and eye wash stations. It's just kind of jarring to see a coffee maker and a critical life safety eye wash station treated with the exact same level of contractual severity.
I get that. But they share the same internal water infrastructure.
Oh, they're connected.
Yeah. If a contractor improperly plumbs the coffee station and creates a massive pressure drop in the system, that eye wash station might not function when a lab technician desperately needs it.
Wow, I didn't even think of that.
Yeah, every single connection is critical.
Which makes total sense. But this actually brings me to a part of the document that genuinely threw me.
Okay.
Section 6. Exclusions.
Ah, yes.
After tens of thousands of words detailing every millimeter of paint thickness and floor friction, the contract explicitly states what it does not cover.
The boundaries of the contractor's jurisdiction.
And the boundaries are massive. I mean, this contract explicitly excludes all demolition work. It excludes below-ground waterproofing. It excludes the entire HVAC system, so no air conditioning or heating at all.
None.
And most surprisingly, it excludes the actual structural foundations of the building.
Yep.
All of that falls under civil works or entirely separate mechanical contracts. So what does this all mean? I really want to push back on this because to a layperson, it sounds entirely counterintuitive.
It does sound a bit crazy.
Right. You have an exhaustive architectural document that governs the entire physical reality of the building, but it doesn't even cover the concrete foundation the building sits on or the air conditioning that makes it livable. How does a multi-million-euro facility not just become a disjointed mess?
It seems counterintuitive until you look at how modern mega project liability is actually structured.
Okay, tell me more.
If we connect this to the bigger picture, heavy infrastructure projects have evolved, become incredibly siloed.
Siloed?
Yes. And the driving force behind this is risk separation.
Can you explain how risk separation works in this specific context?
Sure. You do not want the company that specializes in installing chemical-resistant floors and acoustic timber doors to be the exact same company boring a 50-foot deep concrete foundation into the earth.
I guess that makes sense.
They require entirely different engineering skill sets,
Yeah.
massive differences in heavy machinery, and completely different risk profiles.
Right. The guy painting the walls shouldn't be pouring the foundation.
Exactly. If the foundation settles incorrectly and compromises the structural integrity of the facility, the employer needs to hold the heavy civil engineering firm liable, not the architectural contractor.
So it's about pinpointing the blame.
You separate the risk so that legal and financial accountability is laser-focused. To use an analogy, it's like a complex surgery.
Okay.
You don't want the anesthesiologist performing the cardiac bypass. Both are absolutely critical, but they operate in highly specialized, completely distinct lanes.
That clarifies it perfectly. It's about protecting the overall investment by hiring hyper-specialists and just keeping their liabilities completely fenced off from one another.
Yeah.
But speaking of liability, let's look at the aftermath. Based on the Red Book framework, what actually happens when the building is finally finished?
Well, the reality is, under a FIDIC Red Book contract, the contractor is never truly done just because they hand over the keys.
The document does mention the issuance of a taking over certificate, which sounds a lot like crossing the finish line.
It sounds like it, yeah.
But immediately after, Section 9 introduces the defects notification period, or the DNP. And subclause 11.1 keeps the contractor entirely on the hook for fixing anything that goes wrong. The extended warranties demanded here are intense.
The warranties ensure the structural and functional integrity long after the ribbon-cutting ceremony.
Yeah, the contractor is mandated to provide a 2-year warranty for all interior paint and sanitary plumbing.
Which is standard enough.
Right. But they have to provide a 5-year warranty on those fire-rated door sets and all exterior paint. And then the heaviest burden, a 10-year warranty for the roof sheeting and waterproofing. 10 years for a commercial roof.
That 10-year warranty on the clip-lock roof perfectly encapsulates why this entire obsessive document even exists.
How so?
Commercial roofs endure brutal conditions. They face intense UV radiation. They have dramatic thermal expansion and contraction during day and night cycles. And you have the physical wear and tear of maintenance crews walking on them constantly.
Right, it's not a gentle environment.
Not at all. If, a decade from now, a single drop of water makes it past that 0.70 millimeter color bond steel and ruins an acoustic ceiling tile in an operating room,
Oh, wow.
the contractor is legally obligated to return to the site, identify the failure, and repair it entirely on their own dime.
Which circles perfectly back to our earlier point. The 28-day construction program, the method statements, the sample panels from the pregame, they aren't just hoops to jump through.
No, they are a lifeline.
If the contractor followed the method statement perfectly and the engineer signed off on it, that documentation is their defense.
Exactly.
But if they cut a corner, that 10-year warranty is just a ticking financial time bomb.
Exactly. The paperwork and the rigorous mathematical standards are the only things standing between a contractor and devastating long-term liability.
To bring this all together for you listening, we started this journey looking at the internationally recognized rules of the FIDIC Red Book, which is a framework that basically forces a rigid mathematical order onto the inherent chaos of heavy construction.
From anarchy to order.
Right. And then we zoomed in to see how everyday materials are transformed into life-saving engineering, from scoria blocks utilizing volcanic properties for 4-hour fire ratings, to pandomo floors where R10 slip resistance is a mathematically enforced safety net.
A literal safety net.
We explored how risk is carefully separated, like specialists in a surgery, and we ended by looking at the decade-long warranties that ruthlessly enforce perfection long after the cranes have been dismantled.
Understanding this hidden matrix completely changes how you perceive the built environment around you.
It truly does. The next time you walk through a heavy fire door in a hospital, or you notice an emergency eye wash station in a laboratory, or you just look up at an expansive metal roof on a warehouse, you aren't just looking at metal, water, and glass.
No.
You are looking at the physical manifestation of a massive, incredibly dense legal and technical apparatus. Every inch of that space is the result of thousands of pages of arguments, mock-ups, and meticulously defined liabilities.
It is the abstract law made tangible.
But before we wrap up this deep dive, there's one final detail buried deep in the text that left me with a lingering, almost philosophical question.
How does that?
Deep in the measurement and payment section of the contract, under subclause 13.5, the document outlines something called provisional sums.
Ah, yes. A fascinating inclusion.
The contract dictates that these provisional sums are essentially pots of money set aside, which can only be expended upon the explicit written instruction of the engineer.
Right, it's a reserve fund.
Which makes me wonder, if this entire undertaking is mapped out like DNA, if it is rigidly defined down to the very decibel of a door, the thickness of the paint, and the exact coefficient of friction on the floor, what sudden emergencies, what hidden risks, or what ghosts in the machine are they keeping that secret pot of provisional money hidden away for? What exactly is out there that is so unpredictable it can't be planned for, even with the mighty FIDIC Red Book?
That is the ultimate question of infrastructure. Because no matter how flawless the mathematics, the blueprint, and the legal framework, the earth beneath the foundation always holds secrets.
Something to mull over the next time you step into a brand new facility.
Yeah.
The engineering might be perfect, but the real world is always unpredictable. Thanks for joining us on this deep dive. We'll catch you on the next one.
See the link in the description for free PDF download. Also, watch our other construction scope videos. Thanks for watching. Please subscribe and see you next time.